Hey,
Well, I wanted you to please repeat how you get the past lessons because I tried doing it, but I struggled.
okay. So if you go, let's do this because this is important now. If you go to watobe.co.za, you should see this page. Okay. And if you click on classes and then you click on grade 11, and then you'll see all these things over here. So if you want to go and get some help with number patterns, you click on number patterns, which would be like over here, number patterns over there. So does that make sense?
Yes, sir. Thank you.
Pleasure, man. Good question. Okay, so let's, in the last lesson, we were basically dealing with contingency tables and independent events. And so if you're new today, the students will have a little bit of a head start on you. But yeah, give it a go on the first question of the day, and then don't be afraid to ask questions as we go. So let's start with a question that we kind of did in the last lesson. There's a slight difference. Let me quickly start. So before we start this question, I want to ask all the students, what is different about this question compared to the questions we were doing in the last lesson? So take a moment, and what is different and what's the same? So Tato has said that compared to last time, we have to calculate the missing values, which I think is correct. Last time when I gave you the table, we were simply reading off the different things. And then what is the same compared to last time? So Tato has highlighted that there's this A, B, C, D, and E in the table. What is the same? What is looks similar to the last time we had a question? What do you recognize from last time? Might be easier if you just raise your hand or give me a quick bit of audio feedback. I was thinking, in fact, I don't want to give it away. Come on, someone wants to shine. Who am I to shine when there's so many stars among us? Yes, so the events that occur, and it's this independence, right? So whether or not gender, so male, female, is independent of basically being HIV positive or negative in this particular question. So it's basically, I think this part, this idea of calculating independence of events is very familiar from last time. Okay, let's start with the first question. Let us look at, if I look at this table, how many students are there at the college? So there's a college, and it says here they undergo annual HIV testing, and the results of the tests are shown here. Now, they haven't given you all the information, but I want to know what is the amount of students in this college. Is that information in the table? Pop it in the chat. So it feels like a lot of people are fixating on that number over there, and I would agree. I say that there are 960 students in this thing, because this essentially is the total of both the row and the column. It gives you the same number, 960. Okay, now what I want you to work out A, B, C, D, E, and I want you to put that in the chat. So this is a very common, and if you get stuck, I really want you to raise your hand. So some of you might get stuck, or you may want to ask a question, but for now, see if you can get what A, B, C, D, E is and pop it in the chat. How would we know what A is? What should we be looking to work out? So if I look at the chat, I see Nolotando, Owami, Tato has given answers. And from what I'm seeing, they're saying, look, the total is 192. If I take away 106, so if I go 192 minus 106, I get 86. And I agree with you. Because basically the male and female total for HIV positive is going to be that. Okay. And what about these other ones? Like over here, over here. How are we going to work those out? So I see a couple of answers coming in for B as 528. And if I look at B, you can see it's the horizontal total. So you're right. It's going to be 528. So B. And then if you know what that is, you can work out this one because your total's 960. So this should be 432. So the only ones that we still need to work out are D and E. That's what we need to work out. So I'm going to leave that for you to tell me. Oh, wait, I'm writing this in the wrong place. Okay, so if you want to work out what D is, I was thinking we just go 432. So 432 minus 86, which is going to be 346. Because these two together have to give me 432. And I see lots of people agree with me, which is awesome. And then what about E? How are we going to get E? Jabulani, I see the answer coming through there. So 422 plus 346 must be that total. Yeah. So 422 plus 346. And that is going to be 768. Cool. So if you get a question like this in the exams, it is bonanza, man. Like, this is awesome because you just need to make sure that you know that the row totals go one way, the vertical totals go another way. And so, yeah, that is 6 marks in the bag. Yeah. Lasanda, what is your question?
Sir?
Yeah.
So I wanted to know, is it fine if I didn't calculate the same way that you calculated for D?
Oh, yeah.
I first calculated E. I said 960 minus 192, and then I got 768. And then I took the 768 minus 422, and then I got D.
Yeah. Did you get the same answer as me?
Yes.
Yeah, completely fine. So this is a really good question. Lysander's saying, look, do you have to follow the path I did? No, but we should both get the same answers. So Lysander, while I've got you, as we go towards 13.3, can you give us any tips or hints about how you would start the third question? What do you think? Do you have any, or so if you, huh? Okay. Would anybody like to give us a tip? So I'm going to try now and use the method we used in the last lesson where we look at, can we show whether gender is independent of HIV status? So here is HIV status over here, that's that event, and here is gender. Now, there's a formula when it's written in sort of the most vague way. To show independence, we have to basically show that that statement is true. And in the question, they said to 2 decimal places of accuracy. Now, the A and B are not going to be like, they're just general placeholders. But can I ask you this? What is, let me put it this way, what is the probability of being male in this table? Let me break it down like that. So first tell me, what is the probability of being male in this table? If I choose a random person from this group of people, what's the probability that they will be male? Pop it in the chat there. So the probability that they would be male is going to focus on the total 528, because that's how many males there are. So 528 divided by 960, which is the whole group. So that's the probability of being male. For those of you who were in the last lesson, what do you think the other thing is that I'm going to calculate? The other probability that's going to help me on this journey? So I found that the probability of being a male is what else am I going to, well, over here in the question, what they're asking about, they're asked about male. So here is, what do you think the probability of being HIV positive? Yeah. So what is the probability of someone being HIV positive in this table? If you randomly choose someone. If you randomly choose someone, there's 960 people in the table. And so this is going to be 192 out of 160, right? So let me get rid of some of this clutter because the screen is looking a little bit cluttered, isn't it? Okay, so we found the probability of being male in this group. We found the probability of being HIV positive. Now, in order to work out whether these are independent events, I have to calculate one more probability. What's that probability? I'd love to hear a lovely voice of one of my students. What is the third probability number that I have to work out in order to work out whether this is independent? Come on, you can do it. I believe in you. Aha, Komotsile. And Rodley. Okay, Rodley, can we unmute Rodley? Rodley, what do you think?
Rodley, please unmute on your side.
There we go. Oh, sorry, Rodley, I'm messing with the mutes. Can you unmute yourself again?
Am I on?
Loud and clear.
The probability of being negative.
Okay, it's not negative, but it's close, but not negative. Okay, does anybody else? So if you think of this identity, that's sort of the generic one. I want to know, in this particular situation, what am I looking for? So it's going to be what? Any other ideas? It's going to be male. And what is the probability of being male and HIV positive in this question? Yes, Njongo, that is exactly what you do. So I want to know, what is that probability? Work it out for me. Tell me, look at the table. And what's the probability, if you're a randomly chosen person, of being male and HIV positive? So my eye is being drawn to this one over here. And so it's going to be still out of 960 because there's 960 people in this whole group. It's going to be 106. So 106 over 960. And that's because there's 106 people who are male and HIV positive. And so the probability of choosing someone who's male and HIV positive is going to be that. Okay, now we can determine if the events are independent. Now it's set to two decimal places. So what I'm going to do is I'm going to find out what is the probability of being male times the probability of being HIV positive. And I want it in decimals because the question said to 2 decimal places of accuracy. And that, so let's do that. What is 528 over 960 times 192 times 960? What do you guys get? Times mo. So I get 0.11. Now, what is the probability of being male and HIV positive? Well, it is in fractional form. I've already written it, but 106 over 910. I'm going to use my calculator to be my friend. And it's 0, okay, it's 0.11. You guys, what are you getting? Okay, so in this case, I'll just pull up the answers here because this is from the study guide. 106 over 960, 0.11. And so then the events would be independent. Okay, so therefore, the events are independent. Can you guys give me a thumbs up? So basically, it fulfills the criteria. Can you guys give me a thumbs up if you understand the basic idea of what I was doing there, and give me a thumbs down if you're feeling a bit confused? I just want to get a feel for the group. Okay. So I think that the best way to learn this type of question is just to keep practicing it. And so what we're going to do is we're going to move on to another question now. So Tato, all I did was I was working out, I was basically seeing whether or not the one times the other, okay, is equal to the and part. So I was just checking whether this part, the A times the B, is the same as the A and the B. And because they were the same, we say the events are independent. We know that that is true if we use a different notation. Okay, let's do another question like this, just to keep practicing, because you know how it is. The more you do it, the easier it gets. So over to this question. I want everyone to try and work out the values of A, B, C, and D, and then put them in the chat. We'll go from there. Pleasure, Tato. Pleasure. I'm glad I could help. And then, yeah, if there are any questions now, as we let students have a crack at this question, now is your time to ask questions. I will gladly assist you if that is, yeah. So that is 140. Yep, I agree. And then what is B going to be? So in order to get to 225, 145, so that would have to be 80. Yeah. Now we need C and D. What are we going to get for C and D? So for me, C must be 290 because you've got the 210 plus the 80, which is 290. And then what is D going to be? I'm guessing it's 2, well, I'm guessing it's 285. Yeah. Okay, so I mean, that's 4 marks in the bag. Thank you very much. And so, you know, I do hope that in your exam at the end of the year, you get a lovely missing value in the table question. And that's, you know, part 1. That's sort of the knowledge type of stuff. Now, routine procedures. Now, if you look at this, the question says, what is the probability that a person chosen at random is a female who has not broken her arm? So they're asking, if you choose a random person from this collection, this group, what is the probability that they belong to both the female group and the not broken arm group? And I don't want to say too much. I want to give you a chance to really have a crack at this one. Remember, it's probability, hey? It's not a number. It's probability. And whenever you do probability, you have to have 2 parts. So the one thing I would ask myself is, how many possible students are there? And we know from the previous question that this is the total. So I know that this is 575. The question is, what is this number here? And I look for females. So there's my 2 choices. And I want people who did not break their arm. So that would be 145. Yeah. And if they've asked for decimals, you would just, you know, but that's the correct answer. Yeah, perfect. Okay, what about 10.3? Given that a male shopper is questioned, okay, this is a little bit more tricky. Given that a male shopper is questioned, can you see that we are limiting the group of people? I want to know how big a group is the male population in this question? Because they've been a bit sneaky here. Given that a male shopper, there's a condition attached. How many male shoppers are included in this particular survey? Have a look at the question. They get a bit more sneaky here. So being a male, there are how many males? There are, here's the male row, 350. So for me, there are only 350 people to consider when we are calculating our probability. So what's my probability answer going to be? So broke his arm, it's going to be 210. Yeah. Because here is male and broken arm over here. Okay, now just yeah, give me a thumbs up if you're feeling good, thumbs down if you're feeling a bit lost. Just want a quick reality check to see if we can go on to 10.4. Please, I appreciate honesty at all times because I can't always see your faces. Okay, I hear you. I see the thumbs. People have spoken. All right, so let's try and do 10.4, then we're going to take a break. So it says here, determine using appropriate calculations whether breaking an arm and being male are independent events. Now, it's for 4 marks. So I want to suggest that being male, like we could write like that. Having a broken arm, I'm just going to write broken arm. I don't have any clever abbreviation. What is the third thing that I'm going to have to calculate to help me? I'd love to hear a human voice now. I'm just, I want to hear some people's voices. Who's going to give me the third piece of information I need to find?
There's a hand from Jongo.
Okay, Jongo, what do you think we need to calculate?
So I think it's the broken arm.
Yes, it is the broken arm. So we've got that and the probability of being male, but there's a third one.
Is it the one that says probability of males times probability of broken arm.
Yeah, so exactly that. It's male.
Or
What's
is
the
it the one
probability?
with the and?
And broken arm. That's exactly it. Perfect. So
Oh,
those are the three pieces of information I want to pick up on. And that's exactly that in Django. So can the people of the class please find me? Well, the male one we've already got. Have we got? No, we haven't. Okay, so I want those calculations. What's the probability of being male? What's the probability of breaking your arm? And then I want to know male and breaking arm. And then I think it's time for a break. So pop those answers in the chat. We can even call that a, let's call this 1, 2, 3. So 1. Whenever you do an independent events calculation, you basically have these three pieces that you need to work out, and then you compare them to see if they're equal or not. And we're going to use the criteria of 2 decimal places. That is kind of what they use in matric exams. So that is the, we're going to use. So male for me is 350 over 575. What is, so that's this one over here divided by this one over here. Now, what about broken arm? So broken arm is going to still be 575, except broken arm is going to be 290. Yeah, over 575. And then the last one. What is the probability of being male and having a broken arm? So we've got that, 575. Notice how the total hasn't really changed here. So Tato was asked why 290. So if you look, Tato, at the table, and I'm asking about the broken arm, there's 575 people in total, and if you look at the column with broken arm, it's 290. So does that help a little? So then for male and broken arm, for me, let's make sure I got my breaking arm. It's going to be this one, which is going to be 210. So now, to figure out whether they are independent, what I need to do is times this one by this one and see if it's equal to this one over here. If it's not equal, so it's not independent. If they are equal, it is independent. So let me know what you find in your calculations. Let's find out in decimals here. So 350 times by I get 0.306, so 31. And then for this one, 210 divided by 575, I get 0.37. So the question is, are they independent or they're not independent? That's what I want to know. Let's make this a bit bigger. So because these are not equal to each other, therefore not independent. Now, what I want to make sure, guys and girls, is that you do show evidence that you've done this calculation and that you do make the claim or show the marker that you know that they're not equal. Because often there's a mark given for like showing the evidence. So you do the 3 pieces of the calculation, you then make a conclusion that they're not equal, and therefore they're either independent, or in this case, they're not independent. And so that's how you would get your marks, essentially. Okay, I have been bringing the thunder, and so I think it's time for a break. So what I want to know, or what I want to see, is I want to see the happy faces. Well, maybe happy is a strong word after half an hour of maths, but I want to see the faces of my students. Turn on your camera and just indulge yourself in a lovely stretch. And Lebo, if you could just encourage our students to just stretch it out.
Come on,
Stretch it.
guys, please join us in this stretch. Give your mind and body a break.
Oh, there we go.
Shout out to Bonalo, Kuto, Nolwazi, Rodley, Chohi, Olwetu, Matapelo, Owami, Olwetu. Yes, guys.
Oh, I feel
Don't be
alive.
shy. We love to see your faces.
Yes. I'm like, look at all these other people who are with me. It is so nice. I feel like I'm in a team.
Shout out to Lusanda, Kuto. Your body will thank you, guys. You'll be
Trust me,
so
everyone.
pumped up for this last session.
Oh, I feel so much better. I can't even tell you. My body is just happy with me now. Okay, so after that wonderful stretch, our brains want a little bit of a brain break. And so I want to ask you this question, guys and girls. How many days are there in 4 years? That is the brain break for today. This is an interesting question, isn't it? And also, now you know that there's always a bit of a sneakiness stretched in there. Hey? Okay, so what is the answer going to be? The answer is
Dun, dun, dun.
so I do see a lot of you. I think the first person I have on record here is Hariva, but a lot of you got that right. So there's 365 days in a year, but because of something called a leap year, every 4 years we have February the 29th, and so that is because there's an extra quarter in the cycle of the Earth going around the sun, and so we add that extra day to account for that.
Nice one, guys.
Nice one. Does everybody give me a thumbs up if you've heard of a leap year? Who's heard of a leap year before? Like a year where we add an extra day for February. Okay. So every 4 years, you'll see it's like magic. On the calendar, there's this day called February 29th. And we always used to joke that if you were born on February 29th, you only had a birthday every 4 years, which I'm sure that seems a bit harsh. But I suppose you don't get old quick, so that's cool. Although I don't know if that really
That's an
works.
advantage.
Okay, cool. So let's go back to our questions. So we're going to change the question very slightly now, and this is going to be a more sort of like numbery one, for lack of a better word. And I want to take a bit of time just to unpack this question, because it's not related to a table. It's related to, there's definitely the word independent. So are the events independent? But there's also this thing about calculating P, A, and B, or the probability of A and B. Now, this actually takes us back to another part of the probability chapter. And it's the probability chapter or probability part on something called identities. So I was wondering, can anybody suggest a identity from the section that might be able to help us in this question? So the question says you're given the probability of A, you're given the probability of B, and then you're given the probability of A or B. Now, or is a different word. And then it says A and B are two different events. No problem. Calculate the probability of A and B. Now, that is, yeah, so far today, we haven't really dealt with something that can help us with this, but earlier in the series, there were some other probability identities. Can anybody remember any of them? We can go to a little summary I've got if you like, but I want to give a chance for somebody to, what other important identities are there or facts from probability studying that we know that might be helpful? So let's go back to my little summary. And I want you to have a quick look at these facts. So as you look at this section, there's basically three main identities. Well, 4, I guess. But of these 4, normally for independent events, we look to check if that one is true. But the problem is they haven't given us P, A, and B. They've actually only given us P, A, or B. And I was wondering what identity here has the or in it. Take a moment to look, which one has the or in it? Isn't there something called the addition rule? And we did this when we were talking about Venn diagrams. So I think if I knew what this was, and I knew what that was, and I knew what that was, could I work out what this was? Oh, I think my words are getting a bit jumbled, but the basic idea is that if we've got 3 of these 4, maybe we can work it out using this identity. Yeah, so Kutso, it's the addition rule. Yeah. So let's go back to the question. And can I ask you, can you try and work out for me using the addition rule? So the addition rule for probability says that. And if you go back to the Venn diagram lessons, we talked about it. But just for now, I want to see, can you work out what this is? Because that's what they required in this question. And then we'll talk about 9.1.2. Now, this is a bit trickier. So if you'd like to ask a question, please do. I'm thinking substituting in is probably a good place to start. Like maybe like a 0.2 there. Now A or B is 0.6. So what is that going to have to be? Well, I suppose I could just call it, if I wanted to be sneaky, I could just say, I could call it X, right? You know, good old fashioned equations and stuff. And we could move things around. Or some of you might say, I can see what it's going to be. This is 0.6. This is 0.7 together. So then surely this just has to be 0.1. So that's the one way of doing it, is to just look at it and see it. If you wanted to use an equation, you could just say 0.7 minus x. And then if you move the x to the other side, and you move the 0.6 to the other side, you would get 0.1. So the answer to this is 0.1. Are there any questions about how I got that one? Questions or comments? Okay, now using this new knowledge that you've got, I want you, or you can say 0. Okay, Jabulani, you can't yet. Here's the thing. You don't know that these events are independent yet. They haven't said it to you. So you're assuming that they're independent. but there's no mention in the question of independence. So that's why the identity, that the OR identity or the additive identity, that's true, okay, for all events and all sets, right? So this is a stated truth for probability. In this case, you don't know if they're independent yet. You have to still prove that. So I want everyone to try and now prove, what do I need to show that these two events A and B are independent? What are the three pieces of information I need? Have I got them? And what do I do next after that? So now I need to prove independence. I show that a certain equality is true. Don't I need to calculate what that is, and then calculate what that is, and see? Yes, Nawazi, exactly. So you know that A is 0.2, and you know B is 0.5. So what do you get? You get 0.2 times 0.5. You get 1/10 or 0.1. And what is this one? It is 0.1. So are these events independent? So we know that this is equal to that. Therefore, A and B are independent. Yeah, exactly. So can you see how when you're proving the events are independent, you have to show this. You have to show that this equality holds, and you do it separately. All right. You guys, this is actually can be a bit tricky. So well done. You really are doing quite nicely. Should we do one more like this? Then we'll call it a day. Have you got energy in you for one more question like this? Give me a thumbs up if you do. Thumbs down if you're like, ish, I'm done. I want to see the energy in the room. Okay. One or two students are like, ish, I'm done. Okay. So all I want you to do, we're going to finish with this question. And we're just gonna ask the one that is here. So you're given this information, and I want to know, are these events A and B independent? We can talk about mutually exclusive afterwards, but let's just for now think about independent. What did we do last time, and can you do it again? I suppose maybe I should make this a bit bigger here. Get rid of this clutter. And tell me in the chat if you think that they are independent or not.
We've got this, guys.
Let's do it. I'm feeling lazy, so I'm going to use the X method where I make the thing I'm trying to find X. And if I then bring the X across, I should get so what do I get for my X? So I get 0.585 for probability A and B. And so how do we know if they are independent or not? Well, let's go. Probability A times probability B is going to be equal to 0.45 times 0.3, which is 0.135 is what I get. And the probability of A and B, we already worked out, it was 0.585. And so they are not equal. So therefore they are not independent. Okay. All right. We ran a bit late there, but I do hope that that extra question was helpful. Lebo, if you could pop the link to the quiz in the chat. It's been great teaching you guys today. I hope you learned a lot. And basically, just to let you know, that is our last lesson on probability. We did 8 lessons. And if you did miss the earlier lessons and you want to get good at Venn diagrams or tree diagrams, I would say look at the recordings. And yeah, next week we are doing financial maths from old exam papers. So do come back as we continue with that. All right.